So here's what. These are nearly impossible to do by making a T-chart. If you don't have an idea of what the hell these crazy graphs look like, you would try to graph it with a T-chart and you would graph the wrong thing, right? Because you're like, I'm just going to connect all these random points. And I'd be like, this is wrong, right? So what's going to happen is we're going to need to learn some tricks to this, kind of some structure, some basic things that's like, oh, this happens here, and this magic happens here, and this magic happens here, and then we're going to draw it in really easily. But the first time, I am going to actually plug in points. So you're going to just watch, you're going to write this down. I'm going to show you the weird thing that happens on this weird dude. So here comes the first one. I'm going to graph him. I'm going to plug in points, and I'm going to show you why this guy is so weird. Because the minute we have a variable on the bottom, like weird stuff happens. It's kind of like it just gets all upside downy. So I'm going to start by plugging in the number 1. 1 over 1 is 1. Nice and easy. Yay. You're like, Miss T, that's not hard. I'm going to plug in the number 2, and I get 1 over 2. I get a little fraction. That's not great, but it's not impossible. I plug in the number 3, and I get 1/3, and it's going to go like this. And you're going to think, well, Miss T, I see a pattern here. It probably goes like this, right? But it doesn't. Because watch what's going to happen here in just a second. Every time I put in a number, it makes a fraction, a smaller and smaller fraction, but a fraction like 1/4, 1/5, 1/6, 1/1,000,000th, right? It gets super close to this guy, but it never actually touches it. He's going to look something like this. And watch what happens when I plug in a fraction. This is weird. I'm going to plug in 1/2. If I plug in 1/2, I do that flip and multiply thing, that twirly flip, right? So what happens is I get 2 over 1. So watch what happens here. When I plug in 1/2, I get 2. Oops, I'm going to move. Move, dude. Plug in 2, and I plug in 3, I get 1/3. 4, I get 1/4. 5, I get 1/5. Look, it's that same weird thing. He looks like this. He looks just like this. And he's this weird kind of curvy graph. Well, you're probably thinking, well, you might not be thinking, hey, Miss T, you didn't do any negatives. You know what would happen if I did negatives? The exact same thing. It would go like this. It would do a dude that looks like this, and he would look like this. And you're like, oh, but what happens if you plug in 0? Because you didn't plug in 0. Well, when 0 happens, the whole thing explodes, right? Because remember, we can never have 0 in the denominator. So it's bad. It can never be 0. So that is actually the graph of this guy. But he's got some weird things happening. He's got this weird flippy fraction here and this weird flippy fraction here. And that's what we're going to be doing. But using these points would be a nightmare, right? Because you don't know, like, how the hell this works. But he's got some weird things happening. And the first weird thing is, do you guys remember last year when I said, and for algebra 2 trig 2, you get really close to a line, but you don't actually touch it. What's that line called where it's like that weird barrier? You get super close. Say it. It's called an asymptote. I called it last year what? A lava line, meaning it's made of lava. You can get damn close to the lava, but honest to God, if you touch lava, you come away without a finger. Like, you don't get lava on your finger just comes straight off. That actually happens. Like, people think they can touch it, and they can't. So look, there's a lava line right there. There's another lava line. It's right here, another asymptote. This guy is just going to come swooping in and think, hey, I can't touch the lava. Can't touch the lava. And then he comes down here and he's like, well, I can't touch this lava or this lava. So how we're going to graph this tonight or the next few days is if I know where the lava lines are, then I know how to do the little swooping, right? So that's going to be our goal. Our goal is to say, we don't want to do this. We want to know where all the weird lava lines are so we can swoop it in and swoop it in. Is everybody okay with that? Yeah? Okay. So the first thing we're going to do is we're going to get our piece of paper and we're going to learn some stuff about the key features of rational function graphs. Here we go. First thing you gotta know, it is made up of a fraction, of a polynomial fraction. If it's not a fraction, it's not this weird swoopy shit stuff. I know, what the hell now? Because you know what? Once we got stuff on the bottom, all sorts of bad stuff happens. That's where all those lava lines come from, right? So the first thing is, if we don't have fractions, we don't have to do any of this weird stuff. That's when we just do our up and down like roller coaster stuff. But this happens because we have a fraction. And the way that your textbook, when you go to college next year for my seniors, or you go to calc next year for my juniors, is they write it like this. They call it P of X over Q of X. And that means you're going to have a polynomial on the top and a polynomial on the bottom. And it's really the bottom one that matters, right? Because that makes it a weird rational function, right? Now, it turns out, I'm going to put this like this, so you can write that down. I just don't want you to see this next year and think, what the heck is that P and Q? P is the numerator, Q is the denominator. Now, the next thing we got to talk about this is there are 5 important things. And we're going to learn about those 5 things today and tomorrow. We're going to put them on our graph on Wednesday and do our swooping. And you're going to be like, this is not so bad. But we got to know the 5 important things. Here comes important thing number 1. Sometimes these have lava lines or asymptotes. And sometimes they're up and down. And we refer to that as they might have what's called a vertical asymptote. Asymptote. What a stupid word. And that is the up and down lava line, right? And you can get damn close to it, but you cannot touch it. You will come away with no finger. Sometimes these have flat asymptotes, right? That's when you're a kid and you're jumping around the furniture and you play lava on the floor. You all know what I'm talking about. And you have to jump from furniture to furniture because you can't touch the ground because the ground is lava. You all know that. Shut up. You all do that. I do it. And that's called a horizontal asymptote. That's lava on the ground. Sometimes there are none. Sometimes there's only one. Sometimes there might even be 2. Like you might have an upstairs lava and a downstairs lava. And then that's when you have to climb up the banister when you were a kid. You know what I'm talking about. Yeah, you're all there. Sometimes these guys touch the x-axis. And that is called an x-intercept. And when that happens, it makes our graphing so easy. So easy. And sometimes these guys have a weird thing. It's one of my favorite things. So imagine you've got your volcano and the volcano is dripping lava down the side, but it spews some lava out and a puddle of lava lands right in front of you. You know what you would do? You would walk around that puddle, right? You would be like, there's lava, literally a puddle of lava in front of me. I'm either going to go this way or I'm going to go this way, but I'm not going to step into the lava. And we refer to that as a hole, right? Now, once we know where all of the barriers are, where all the asymptotes are, where all the holes are, and we know where the x-intercept is, then we can do our little swoopy lines. And we do the little swoopy lines by doing a baby bit, a tiny bit of plugging in. We plug in only like 2 or 3 numbers, like not a ton. And we pick really easy ones, right? And then it's going to help us do our little swoops. And that's it. That's how we'll graph. Is we'll figure out all this stuff, and then we'll swoop it in. And you will like it. It won't be bad. So let's take a look at a graph, and let's see if we can eyeball all of this stuff. You guys ready? So here comes our first one. Here we go. So this is true. This is this graph right here. If you put this into Desmos, that's what you would get for that crazy graph. Look how scary that is. Who would ever want to plug in numbers? Bless you that. No one would. So let's figure out his important parts. Are you guys ready? We're going to do this together. So I want you to use your pencil, and I want you to talk to your neighbors. Can you see the lava line that is flat that they cannot cross. Can you draw it onto your drawing right now? There's a line on there that neither of these lines can cross. They get close to it, but they don't cross it. See if you can put it on your graph. I think it's right here. You guys see it? That's our horizontal lava line. And you know what we call that? It's a horizontal asymptote. And that's a heart rate problem. So what we're going to do is we're going to put our little heart there. That's on the y-axis. So we're going to say y equals 1. Super easy. Super easy. Can you just put 1? No. It's a line. It's not just a number. It's a line. So it's y equals 1. How about with your neighbors, can you find the up and down asymptote? Can you draw that on your drawing? See if you can find it. Draw it on. I'm going to draw it on in purple. I feel like it's right there. There he is. Hey, he hit at X. So he is X equals 3. You cannot just put 3 because I won't know what you're talking about. It's a line. How about does he cross the X-axis somewhere? Take a look at your drawing. Make a nice big dot where it crosses the X-axis. I'm going to do it in green. You see it on your drawing. Right here. Now, I can't just put -2. It's a point. And it's an easy point. -2, 0. Super easy. Yep, wherever it crosses the x-axis. Now, the last one is my favorite because it literally is a hole. Like it's not trickier than that. It's a literal hole. There is a literal puddle of lava right there. That is a place that my graph has to go around. It's the craziest thing. And you know what that point is? That point is 2, -4. It's a hole. It's a literal hole. Okay. Are you guys ready? Oh, that sounds so good. Are you guys ready to try one on your own? There you go. Give it a shot. This is the second one. See if you can find all of the parts with your neighbors. Have them help you find and you don't have to do it in that order. Do whatever order you want. Sometimes the answer is none. Like, it doesn't look like it hits the x-axis at all. That's okay. You can write none. No, because it hits it's crazy. It hits the Y line. Right? I know, yeah. And I literally make it like, I put the little heart on it because it will tell me, like on this one, see it's right here. So I put the little heart right there. Does that make sense? Oh, so let's start with this one. So here I go. I'm going to start with my vertical asymptote. Do you agree that it goes like that, right? So I go to the axis he hits, right? And he hits right here. Are you cool with that? So it's going to be x equals -2. If you want to just memorize that the vertical asymptote is always the x guy and the horizontal is always the y guy, you can do that as well. Thank you. Hold on a second. She's always somewhere. Like she got called to somewhere else. Okay. Okay. How about our horizontal? Let's do him in blue. It's this guy right here. And you know what? He hits this axis right there. So it's going to be y equals 0. Now, you know where he hits the x-axis? Nowhere. He doesn't hit the x-axis anywhere. Does it kind of bum me out? Yeah, but Nowhere. So none. Boo. It happens. And I got one little hole, one little pot, one little puddle of lava. And this little puddle of lava is at -4, comma, oh, -1. Is that right? Okay, last one, best one. This is the weirdest one because sometimes you might have more than one lava line. You might have more than one x-intercept. That's okay. And maybe you'll have no horse, like, see what you got. So can you have none? Yes. Can you have more than one? Yes. Right? Just take a look at it. See if there are places where you cannot cross. There might not even be any holes. It's kind of sad. None. Look, though, I hit the X a lot of places. Ooh, lots of those. Here are my lava lines. There's a lava line. And there's a lava line. What are you thinking? So here's what my x-intercepts, I got a lot of them. It hits at -3, but don't put -3. It's -3, 0. It hits at 0, 0, and it hits at 3, 0. We're a pre-count now. We can't just write -3, +3, 0. That's not correct, right? Vertical asymptotes. I got 2 of them. Looks like it's going to be x equals -2 and x equals +2. Someone in 0 period said, could I make it plus and minus? You cannot. They're separate lines, right? X equals -2, x equals +2. They are individual lines. Horizontal. Guess what? Everything's fair game. There's nothing there's no like lava on the floor on this one. So none. Okay. So here's our job. Everyone, yes. Holes would be if I had something that looked like this on there. It's literally a hole. Yeah? Okay, so here's where we're heading. I need everyone to watch. So I'm losing you a little bit. Tim, our goal is to take this on Wednesday and get to this. And the way we do that is by figuring out all of this stuff first, putting it on our graph, and then drawing the swoops in. So I need to teach you how to find that stuff from the equation. Are you ready? Turn your paper over. I have got the steps on it. Jackson, you don't want to lose this because this is literally your little instruction manual of how to do this. Are you guys ready? Here we go. Today, we're going to find 3 things today. We're going to find the x-intercept. We're going to find the vertical asymptote. We're going to find the holes. We're going to wait and do horizontal tomorrow because your brain would explode if we did this all today. I think some of you did this now, but you triggered one day and there were tears. But we are going to do it nice and slow, okay? So, first thing is, here's our equation. That's a bullshit equation. I want it in factored form because my life is better in factored form. So can you please, my sweet, sweet lambettes, can you factor this so it looks like this? F of x equals, give me something on the top and give me something on the bottom. It's x factoring. It's not scary. It's nothing hard. Factors of 3 that subtract to be 2, 3 and 1. Factors of 2 that add up to be 3, 2 and 1. Yes.
I got a pass for you.
Thank you. I got it.
All right.
Mean? That was so awkward. That was so weird. sometimes, do you remember there was a little girl last year who did, and she was in a special ed program, and but she was like this super quiet, and she'd come up like right behind the teacher, like I must have hit her like 3 times, like someone would go, Miss T, and I would turn, and she'd like I'd like plow, like she'd get like this close to it. Like this, like, you're like, oh my God, almost took her out. Okay, are we there? Everyone good? Okay, now the next thing I need you to do, we're going to simplify this, dude. We're going to cancel some stuff out, but I need you to cancel lightly. I need you to take your pencil. I need you to cancel stuff that can cancel, but very lightly. In other words, this husband and wife can go, and this husband and wife can go. And you're like, let's see, why are you acting so weird about that? You're going to see why in a minute. So here's what we have. X minus 3 over x plus 2. Is everybody good? I am not going to lie. That's almost all the math. Everything else is just figuring out where you go in your pantry to make it cookies. We got to get the chocolate chips down. We got to get the flour down. We got to get the brown sugar. So here we go. We're going to find the x-intercepts. It's very easy to find the x-intercepts. We go to the numerator, and we're going to steal the numerator. Here he is, right here. We're going to steal him and set him equal to 0. X minus 3 equals 0. I'm putting a big giant N here. We steal from the numerator. So in other words, x equals 3. An x-intercept is a point that will be 3, comma, 0. It's so easy. We steal from the numerator, right? Everybody good? Now, to get the asymptote, we do something a little different. To do the asymptote, we steal from the denominator. Here's why. Anything in the denominator explodes our fraction. So we don't like stuff in the denominator. Remember how last week we kept saying -2 is a bad number? Well, it still is. It's an asymptote. So we're going to come over here and say x plus 2 equals 0. Look, I'm going to highlight this guy. Or x equals -2. And look, the x automatically shows up when we do it. So that's our up and down asymptote. Now we got one last thing to figure out. It's my favorite thing. Takes a little bit of math, but it's super easy. And it's my very favorite. The last thing is to find the holes. And the holes are this weird puddle of lava that's so bad. It's so bad, it showed up on the top and on the bottom. Is there a thing on our original problem that showed up in the top and the bottom? Canceled it. What is it? X plus 1, that is going to be our hole. That's why I'm saying don't scribble it out. So we're going to say x plus 1 equals 0, or x equals -1. Now there's a little bit of an issue here. This is a point. It's -1 comma something. And we need to get that something. This is the only math that you have to do. And it's not hard. We've got to take that -1 and plug it into our fraction up here. So we're going to say x minus 3 over x plus 2. We're going to plug in that -1, right? So we're going to say -1 minus 3 over -1 plus 2, -4 over 1, -4. And that's all the math. It's a lot, but these are crazy graphs. These are crazy graphs. This is what we're doing tonight. We're going to practice this. You guys ready to do one together? Are you ready? We got this. Okay, here we go. Keep this ready. This tells us how to do it. Oh, look at this. I'm going to make this really pretty. Hold on, in case you want this. There's the hole. Look at that. I'm going to go to find the hole. We do this guy. Phew, see, it's all color coordinated. Okay, here we go. Here we go. Step one, factor. We don't like it this way. We want to factor this here. So here we go, my lambs. Let's start by taking out the 3. We'll have x squared minus 4. But you guys could even factor that a little bit more. I'm going to give you a little hint. It's going to look like that. X squared minus 4. X plus something, x minus something. We're factoring the top. See, then you're going to owe me another box. Okay, did you guys get x plus 2, x minus 2? Yeah, are we cool with that? How about the bottom? Can you guys factor the bottom for me? X squared plus 2x minus 8. Guess what? That's just x factoring. It's not scary. You guys could do that. I'm going to write it nice and big here. Anyone brave enough to tell me what they got in the bottom? X plus 4, x minus 2. Nice. Okay. Do a little canceling, but lightly, right? Don't like scratch it all out, because we'll need it for the whole, right? So very lightly, very lightly. So here's what we have. We got 3 on the outside, x plus 2, and x plus 4. Have I lost anybody? Everyone's good. Now we're going to go back to our little cookbook and see what we need to do. Let's get the x-intercepts. The x-intercept says just use the numerator. And here's what's cool. I don't even care about that stupid 3. I can ignore him. I'm just doing this dude. So I'm going to say x plus 2 equals 0. Some of you are going to get really fast at this and say, Miss T, can I just go straight to x equals negative 2? You can, but don't forget, he's a point, negative 2 comma 0. Nice and easy. Some of you are going to get really fast at this. How about the vertical asymptote? Do we use the numerator or the denominator? Denominator. Keeping you awake there. So I'm going to say x plus 4 equals 0, or x equals negative 4. He's a line, so that's perfectly cool, just like that. And the last one is their puddle. That was so impressive that he's in the top and the bottom. There it is. It's this dude. So we're going to say x minus 2 equals 0, or x equals 2, but we need his partner. I want you, with your table mates, to plug in that 2 into this guy, into that guy, into this simplified guy. So 2 plus 2 over 2. You cool what I did there? Did you get 2 again? Nice. Nice. Okay. One all by yourselves. All by yourselves. Here you go. Now remember, sometimes you might get none. That's okay. None is fine. You're trying this one all by yourselves.
Oh, that one?
Some of you are going to start getting fast at this. That's totally cool. Like you're going to be like x minus 2 equals, you're going to go like, oh, that's just 2. X minus 7, that's just 7. Right? You're going to get faster. I'm going to do it in just a second. Make my homework out while I'm getting it going. Yeah, yeah. Yeah, so just it's gonna be nice and gentle. So it'll just be a 1 on the top over it. Does that make sense? It's just done. There will be none because you canceled out, right? And that's okay. I might be not going to. Okay, let's take a look and see how we did. Here we go. Nice, easy. Super, super easy. You're going to be like, Miss T, I get this now. X plus 3 on the top. X plus 3. X plus 5. Little bit of light canceling. Light canceling. I can't have nothing up there. So here's my fraction. 1 over x plus 5. What are the intercepts? None. Because there's no x left on top. So there, x doesn't equal anything. So the answer in this guy? None. How about the vertical asymptote? Now we go downstairs. And you know what it's going to be? X equals -5 for my friends who are getting fast at this. And then finally, do I have something that was so powerful that jetted out of my volcano, made a little puddle? Yeah, it's the x plus 3. Or in other words, my hole is at -3 comma something, right? How did I know that? I went x plus 3 equals 0, x equals -3. Now, I'm going to plug this into this guy to get his partner. Nice and easy. 1 over -3 plus 5, which is 1/2. How do we do? Okay, let's take a look at your homework, and then I'm going to shut up. I'd like you to try a few before you go. First thing is, turn it over. This is it's called a cyclical review. I do not have a day where we just take a practice test. So I'm doing a little bit every day. Do not blow the back ones off, but you can. But then come Friday, you're going to be like, you didn't give us a review on that. I'm like, didn't I? So there you go. Here's the first side. The first 2 are just the ones we did where you just eyeball it. You don't even have to do any math. Just eyeball it. Like, draw it on there and put it on. We like those ones. And then the next ones, you're going to have to do the math because I will give you a drawing. Can you skip number 8? Sure, I don't really like number 8. Number 7 has a little bit of rainbow factoring, so don't be a baby about that. The answers are on your desk. They will also be in Google Classroom. Do at least 4 before you go, then I know you got this now, right? And then tomorrow, did you notice what's not on here that we didn't do? Horizontal asymptote. You see, I blanked it out because we're going to do it every 2 days. We're not doing it all in 1 day. Okay, I'm done. Goodbye, my friends. I am going to